be up in a moment, and then we will get going. There we go. Ladies and gentlemen, welcome to Syndicate Talks Season 2, Build Cool Shit. Welcome back. Christmas trees in the background. Colorful sweater is on. It is December 18th of 2020, and we have screened through this year. So if you are live watching from YouTube right now or anywhere else in the world, I want to ask you a question that I can't see your hand up for a moment. Who thinks this year is both the fastest and slowest year we've ever had? I'm sure my panel can agree on that for a moment. But to entertain, titillate, and educate at the same time, because Syndicate Talks, of course, is about you and building education for you, for your business, and sometimes even life in general. Today, I put a panel of incredibly smart individuals together on this call to answer something wonderful, of course, at a time of year that has stresses, pressures, etc., but also has moments of joy. Why? Because this stuff is pretty cool. And how do I know it's going to be pretty cool for you to listen to what these guys have to say? It's simple. They've spawned entire television channels and series, TLC, Discovery, etc. If you spend any time during the day on regular broadcast television, what these guys are going to talk about today is the stuff you keep signing up and watching on TV. Now, build cool shit. What does that even mean? The world is both more complex and more interconnected than we really realize. From the streets, cities, and avenues that we drive on, live on, work on, thrive, and grow ourselves on, to the homes that we see a lot more of right now in the midst of a worldwide pandemic, maybe more than we really want to, right down to technology and the way technology works for us to make the world we're encompassed in right now, in the middle of a pandemic, work much better, much smoother, much more easily. Now, each one of these elements are incredibly complex and they're incredibly vast. And just this phone and just the software that goes into it, there's dozens, hundreds, thousands. In fact, I have hundreds of apps on my phone right now, which means there's hundreds of companies employing hundreds of people to build the things, whether it's from banking information to email communication, phoning, or just plain up entertainment, like one of the games that I'm addicted to right now on this. All of those have a vast amount of information, development, time that goes into it. Well, is that any less complex than what it takes to build this Christmas tree with blinking lights, or the house that's sitting around me right now, or the houses that occupy the street that I live on, the street and the neighborhood that we're here, or even the city or town that you find your home lives in? Each of these from an individual perspective is incredibly complex. They take a vast amount of resources, energy, dedication, and even human hands to do it. And yet, when we stop and look at how complex, how deep some of these pools could be to dive in for information, actually how closely connected they become. Simply because I can start that whole chain of conversation from this thing, the device, right? I could start from this device and work out to, I use this device to build a website, and I use the website to get somebody to call me, and that person to call me wants to build a house, and to build a house requires engineers, construction, plumbers, permitting, etc. And then from there, the house gets built into a neighborhood with other houses being built. So cities need to be planned, and streets and avenues need to be planned out, plotted out, and all of the resources that comes in. So I can start from this and work out to where I have multiple houses, streets, avenues, etc. being built, or just to come down to the device to be used to do something like a website to get a person to call me because in my house, I've built a business. That could all start because somebody somewhere planned to build the place to put the houses for me to move into, to satisfy my needs and wants for food, fire, and shelter, to give me the opportunity to take the device and build something to get them to call me to build the next neighborhood. Each one of these can stand alone, but yet the interconnection in our lives, I was just about to say my life, but our lives collectively, is surprising how straight a line you can draw from one end, the idea to start a brand new neighborhood, right down to where this device allows me to communicate with people. And so we sometimes don't think about it unless we're watching TV during the daytime and we're on TLC or Discovery and we want to watch people build cool shit. Well, my panel knows how to build cool shit. From the outside world, planning and implementing from a street to multiple homes to cities, to the individual home you sit in and all the components that go into it, right down to what makes this work. I put 3 really smart guys on this call today simply to talk about how we can start at one end, go to the other, and capture them as experts in their fields, just to talk a little bit about how even this can go out to building a city, or from a city can work all the way down to here, and how that can connect, and even amongst their lives and their professional backgrounds can be so deeply interconnected from device to home to city street. So joining me today is my partner in crime, a good friend of mine, Mr. Ben Arledge, of course, Mr. Michael Oleskiw from CVL Engineers, and my brother from another mother from over across the pond, Mr. Gary Rowland. Now, I'm going to let them talk a little bit about themselves, because while I got the gift of the gab, I don't think I can do justice to their background sitting here right now. So I'm going to open the floor. Ben, give people a little snapshot on what it is that you do on a day-to-day basis, and what it is when it comes to technology specifically makes you the person that in the next 20, 25, 30 minutes, you're going to be able to help to educate them on this a little bit. And then I'll skip to Michael and go to Gary.
Sure. Thanks, Mitch. Ben Arledge here. I build apps, web apps, but most importantly, I help businesses figure out their business models around technology, solve problems within their businesses. So that can be something from a basic website to a custom piece of software, mobile app, getting them on the cloud, things like that. Just getting to know their business intimately and solving some of their key pain points. That's really what I do.
Fantastic. Ben, thank you very much. Mike, you and I, of course, got to know each other really well over the last year and a half, but you're here because you can talk most of all out of everybody here. So Ben can talk about the technology and very intimately and specifically what goes into something as simple as the device, the website, or even our ability to do this right now, thanks to Zoom and on YouTube. But you can talk very specifically to the outside world itself. So fill us in a little bit.
Yeah, Mike Oleskiw, President, CVL Engineers. We do civil, structural, and geotechnical engineering. We've been around for about 4 years. And I mean, our mission is the tagline for this chat we're having is to build cool shit. Because the reality is that everything is cool to somebody for some reason. Whether it's you're remodeling your bathroom because you want it to look nice, or it's building world-class facilities like Rogers Center here in Edmonton or the Eiffel Tower in Paris. Like there's no limit to what we can build. Physics might have to figure some of this stuff out, but I mean, if somebody can dream it, that's somebody can build it. We don't call them tricorders, but we have tricorders. They've been around since Star Trek came out with them, and now Ben develops apps to use on them.
Fantastic. And then, of course, Mr. Gary Rowland. Fill us in, brother.
Beam station engraving. So I have a marine engineering and a IT background, and I've combined the two of those to create cool shit from pretty much anything. So whether it's signage, promotional, I can burn it, print it, or embroider it. So whatever's needed.
Now, very modest men doing very extraordinary things with their brain. Ben, how many individual people's lives do you think the software you've built in the last year or 2 years have touched? Thousands, tens of thousands, hundreds of thousands of lives?
Definitely thousands. I probably should spend a little bit more time on the analytics to find a real number, but yeah, so many different cool projects. One recent one was a raffle app, so helping nonprofits and charities. So we've been able to help dozens of charities so far, and we're still very young. And this app is to raise over $100,000 so far. Impacting thousands of people. perhaps hundreds of thousands. So yeah, it's been good.
Absolutely. Now, Gary, once again, smart people, incredibly modest. So I'm going to keep putting them on the spot for a moment, and then we're getting to the actual meat of what we're talking about today. Gary is sitting in the house that he built by hand. So very modestly, he says, I'm a marine engineer and I have a background in IT, and he doesn't tell you who he worked for at IT or where he worked in marine engineering or the fact that he does laser engraving right now. But when he gets bored, he decides to build a palatial house by hand, including pouring the concrete, etc., straight down to there. And yet here he is telling you that if you need something embroidered on your coat, that's the most amazing thing he's going to do today. While he sits in the basement of the house that he built every stitch of it by hand. And then, of course, there's my guy, Mike, who I know has done some extraordinary, incredible things. So to reset, Ben's got a cool project. Gary, give me a cool project. Mike, you're going to give me a cool project. And then we're going to start talking about how all of it connects together and what building cool shit is really like. Gary, what's the coolest thing you've done in the last little bit?
In the last little bit? I have no idea. I built some signs, but not just your average sign. The sign was actually in three-dimensional acrylics. So it was actually constructed using advanced adhesives and acrylics laser cut. And then it was built to provide a three-dimensional profile off the wall.
Now, I put Gary on the spot deliberately for a moment. I've been changing the way I start interviewing for a reason. Is the moment you can get somebody to talk about what they're doing, they talk about all the things they take for granted at hand, and yet there's going to be a number of things you just said there right now that people have no clue or no understanding how that goes together, and yet that's already talking about building cool shit. Mike, what's the coolest thing you've done in the last little while?
The coolest thing we're doing right now is probably a project in Vancouver where we're involved with putting in water intake pipes. I mean, it sounds very blah to probably a lot of people, but I mean, every single home, every single house, every single office has a tap, and that water has to come from somewhere and has to be treated, has to be transported, has to be maintained. And that's what drives the modern world. And there's thousands of these pipes and cables and wires that exist under the ground that no one ever sees and that nobody really talks about. And the complexities that go into it, especially in a place like Vancouver, where you've got seismic considerations, you're right next to the ocean. The project in question we're working on is actually directly underneath the Lionsgate Bridge. Like, those are all aspects that you have to take into account to do a project like that.
And now you guys are starting to warm up. So I'm going to back up for a moment, and Mike doesn't even need to reference anymore to talk about some of those things that go in there. So something as simple as a water pipe. I'm going to be a complete Luddite, a complete layman, and say, okay, great. So you're talking about the stuff that goes under my house where the toilets go out one way and the water that I drink comes in the other. Very, very cool, right? And my brain cannot wrap itself around it being more complex than that. But considerations and information like that goes into what builds the complexity in something as simple as me being able to turn on the tap and get fresh water in my house. Never mind all the interconnections that gets you to the point where you're doing that. And while Gary's talking about his project, just building an acrylic side with advanced adhesives and that, knowing his business in the past, we think of that. In Gary's brain, he goes, well, I just put the acrylics together and I find the right adhesives and I make it together. And it's this massive. Well, I've seen the kinds of signs he makes, firsthand. Why I've asked him to come and interview today is because in his brain, the complexity of this has disappeared. But people will look at the product he's built, and now you're thinking, oh, like something to go up on the wall of my office, or something that would go in my kitchen, or maybe something that's 4 feet high that's hanging on the side of a building. And then because that sign has to go up on the side of a building and it's built in 3D, so it has a sense of depth and adventure, it matches artistically, it matches by material, it can be backlit, it has to be mounted to the material, it doesn't fade in the sun, it doesn't become brittle and crack in the winter, because we have vicious winters where we are right now, et cetera, et cetera. So all of these details, when we talk about the complexity of building the things in our world, now you guys are starting to get the context of where something as simple as, well, I just built an acrylic sign, can be an incredibly cool thing for us to talk about the world. So each one of your projects, I want you guys to fill in a little more detail for a moment. And then I want us to start to talk about how each of those actually builds an interdependency between one of each of you from an expertise standpoint, simply because it requires one end to the other, from something as minuscule or small as technology app building, all the way out to building the infrastructure to put in brand new lines, pipes, water drainage, etc., in a seismically challenged area under a bridge through other commercial, residential, and industrial. That is, for Michael, it's like, oh, well, this is just what I do on a daily basis. He goes, I just built a sign for what I do for it. And Ben's like, yeah, I just built this app that helps charities find, sell, collect donors, create revenue, and sustain itself. I just built this little app. It's okay. So guys, the challenge, the gauntlet has been cast out there just a little bit. Ben, it's not just an app, because the complexity that goes into it to build cool shit is quite a bit more than, I just built an app and it's helped a few thousand people and it's generated a little bit of money and done some stuff. It had to start from an idea, it had to start to ideation, it had to go into design, it had to interconnect, and then in the case of lottery, it had to work with government agencies and organizations, it had to meet certain restriction strictures, it had to create a vetting process, it had to be certified, the company had to be above board to even interact or work with charities that are inside of it. So these are the things that I hear and I see when we talk about this, and that means that you didn't just build software. You didn't spend 8 hours a day for months on end just typing code into a computer. All these other parts that go into the complexity of building something as cool as an app that helps.
Yeah.
Thoughts?
Yeah. And there's a lot of resiliency that needs to be considered when building, something that might appear simple on the outside, but has some complex inner workings. So for the raffle app, for example, we're on AWS, which some people may not realize runs roughly 40% of the internet, which is huge because they probably make more money on AWS than they do on Amazon.com. Now, for the raffle app, we had to consider that, we're going to get slammed at times with people trying to buy tickets. Look at the Oilers lottery, for example. So we had to build it in a way that was, each part was kind of segregated from other parts, so that, the whole thing didn't crash at once. We could have, some parts suffer performance, but still keep the entire system up and running. So we had to do what's called microservices, things like that. The planning that went into the app, before we even started building was hugely important. Like I'm sure, Gary and Michael can attain to. It's that pre-planning, in the case of, engineering or blueprints or designs beforehand, and those are even more critical for them. For my side, in the digital world, I can make a mistake and fix it. So I'm a little bit more fortunate in that scenario. But there's a lot of cases where that planning has to be done beforehand, and there can't be mistakes, or the mistakes, are going to be very minor, at least, or fixable, right? So, so there's a critical part to even starting before starting any type of project that I think we all share.
So now, as I'm changing the interview styling as we come into these to more interview, I'm also trying to walk, if you will, my panel into certain things. Because Ben, you just said something incredibly important. I'm going to get Gary and Michael's take on that for a moment. But we look to build cool shit, even in a software world. And as you said, once again, tongue-in-cheek, it's like, yeah, even if I make a mistake, I can correct it right away. But there's still a certain element of planning and implementation. And depending on the complexity of the kind of work, building just an acrylic sign, or, just doing water table surveys, seismic engineering, and then otherwise putting another tube in the ground so when I flush the toilet, the water goes someplace that isn't my basement, right? So even just doing that, there's an enormous amount of planning at the front end. So Gary, Michael, any thoughts to add to Ben on that right now? Because I'm going to guess that everything we look at in life that we think is something so simple, even this pen. time has to be put in before we even build the pen or sell the pen, before we can turn the pen over to somebody else, simply to figure out what we want the pen to do and how we want it to work. Gary, Michael,
Well,
thoughts?
100%. I mean, like there has to be planning that goes into it. And I mean, but it's not just planning what it is that you want to do. I think that there's more, and technology has iteration capabilities that unfortunately a lot of other things don't. But I mean, it, by that virtue, I mean, there's so many other aspects besides just the plan. You know, you mentioned, like Ben mentions AWS, that's what it's running on, but I mean, there's other stuff that it could be running on. Like, it's not, you know, for us as engineers, I can build a home out of steel, I could build a home out of concrete, I could build a home out of straw. They, you know, it's not very common nowadays, but, or more specifically in North America, but you know, the first settlers to North America built sod houses. They find remnants of that stuff still, and there's still one standing. Like it, so it's not just what's the plan, it's also how are you actually executing plan, and planning the plan. And it's, you know, that aspect of it also plays into it, because, you know, using right now as an example, it's actually cheaper for some applications to build with steel because wood's so expensive. So, you know, how do you coordinate all of that? How do you incorporate all of that thought into the plan? Because you could come up with the next Taj Mahal or something great, but I mean, if you can't afford to buy the mortar or the concrete or whatever it is, like, you're kind of SOL. Like, it's, and I imagine that the same holds true for Gary. Like, an acrylic sign is great, but I mean, if the color that you want is going to cost 10 grand and you got a budget of 3, well, you're not using that color.
Yeah, I mean, one of the things that we benefit from in the engineering space is we can do prototyping. A lot of software these days, particularly like AutoCAD, that type of thing, and they give you the ability to be able to do virtual prototyping where you can actually see stressing within the materials. So you can use that as a preliminary way to establish whether your design is actually robust enough. You prototype in IT as well. So you actually do a first iteration, and that's what Michael alluded to earlier, is iterations. So you can actually do a prototype, you can present the prototype, it has a specific use case, and you can actually then prove that's going to work based on a scale model, for example. So you can build scale models after you do the software prototyping. So there is a level of being able to establish that your design is robust through a learning curve. Because if you do the prototype and it doesn't work out, then you fix it through the prototype. It's no different to what they've done in the past, pre-computers. And I do that myself. If I'm unsure that something is going to engrave properly, or I want to make sure, because if somebody gives me a one-off product, I have one hit at getting it right. The same as building a bridge. Most of the time you have one hit at getting it right. So you have to do some preliminary work to make sure that it actually is going to do what it says it's going to do. And if the prototype doesn't come out right, then you have to look at what failed, and you fix it through the next iteration.
Ben, any thoughts to add?
Now, I mean, a lot of this is based on economics too. You know, we have in different industries and technology and such, where the methods and the materials are constantly changing. So we're not only trying to keep up with our competitors, but new technology, things like that. So there's a lot of work that goes into keeping present and keeping competitive. And that, I think, is often overlooked when people try to look into the services of a technology provider or an engineering firm or a builder. Is, you know, the work they have to do day in and day out to keep current.
Now I've walked you guys into the sweet spot, if you will, because you're already warming up and you're starting to problem solve. So I want the 3 of you to talk out loud right now how we would design, plan, manufacture, build, and sell more of these pens. Because you guys just talked yourself into the parts that you take for granted. But I'm going to go back, and I keep referencing TLC and Discovery Channel for a moment because it's simple. It's really simple, and History Channel too. It talks about all the parts that for people as experts we take for granted. And now part of my purpose today isn't just to show you guys off and go, Gary, talk about some of the cool stuff you build, and Michael talk about the cool stuff you build, and Ben talk about the cool stuff you build, and here's a little bit of gloss and a pat in the back. Oh, heck no. No, that's not what it's all here for. No, 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 no. Right? No. Everything is more complex simply because most of us, to buy this pen, don't think of it if we find it on a website with a device or the computer that we're connecting with each other on right now, in a store, in a retail space, whenever we can go back to them, because somebody else is carrying it, etc. And yet to build this pen, no different than that tree behind me, or the house I'm in right now, or Gary's house that he built by hand, or the office building that Michael's in, or in Ben's office in his home where he's at right now, or the street that our house sits on, all started at the same place. Somebody had the idea to do it. To take the idea, we had to look at it. We had to battle plan. We had to plan about it. We had to build something. We had to look at iterations. We had to problem solve and troubleshoot. We had to build to stress test what was going on. We had to equate from an engineering standpoint, what would happen, what if, do fault planning. We had to budget. Building a pen isn't as easy as me getting 3 incredibly smart guys, even though Gary's already figured out how to build the pen, even how to engrave it, because it's got some cool engraving on it too. But from there, have to figure out how much it's going to cost, then figuring out what to sell it for. So Ben building software and Gary building a sign and Michael doing infrastructure for residential, commercial, municipal use, all has to start from one person had an idea to do it. Then we have to prove whether or not it's viable. Then we have to plan. Then we have to mitigate. Then we have to budget. Then we have to build. Then we have to deploy. For everything in our life right now, from a complex side of things, from the sweater I'm wearing, the tree over here, the pen, the chair that Gary's sitting on, every one of those has to start and end in the same spot. So I'd like you guys to talk me through, and I guess I just talked about it out loud, what it would take to build this pen.
That one.
3 of you, I need you to build me a better pen.
Oh, a better pen? Okay, this is a good start. So we need to start with the requirements. What is it that you want the pen to do? Do you just want it to write, or do you want to bring it into the new world? And if you're looking at the Industry 4.0, which is where we're bringing in artificial intelligence and machine learning, do you actually want that pen to do more? So, for example, if you wanted to have an IT element into that pen, do you want it to actually record what you're writing by hand and automatically putting that into a computer so you've actually digitized your handwriting? Do you actually want to have it where it has a presence, it knows where it is, so Michael could actually take it on site and actually touch it against different elements of a building, and it would map out that building because of the GPS technology built into it? So again, now you're taking something which is an ordinary device, bringing it into a new world, but also making it a differentiator where it actually becomes something of value to a lot more people that wouldn't normally write with a writing instrument. Just a thought that just entered my head while you were talking about it. So.
Michael, Ben, thoughts?
Yeah. Well, first, you could even ask what is the problem you're trying to solve with a pen? Maybe you just need a Google Voice or Alexa to solve your problem. Maybe you don't even need a pen. But yeah, what Gary said, there's so many, digital possibilities with that as well. We've got an iPad, which you can use your pen on there to draw, right? Things like that as well. So
why don't we actually incorporate the Alexa or the Google thing into the pen, so you don't actually have to look for the device? It's actually in your pocket, listening to everything you say.
Yeah.
Michael, anything to add?
The question and Gary and Ben's idea, I mean, like it reminds me of an old story that I'm sure everyone's heard, and like it's not true, but there's the old story of like NASA spent $1 million developing a pen that can write in space, and the Russians just used a pencil. Like a better pen is important, but going back to some of what Ben was saying and Gary, it's like, what do you need it to do? Like, a pen with all of this functionality is great, but I bet you it's probably not $1.99. Not today anyway, maybe 50 years from now. But if you want to sell a high class, high end pen that does all of these things and somebody's willing to pay $1,000, then great. But if it's a pen that somebody wants to pay $1.99 for, that has to be taken into account. Will this pen be robust enough to go sit in your pocket while you hop in your truck and drive to McDonald's to pick up a coffee, and or you're wrangling your 4-year-old? What's all of the rest of the aspects that go into it? Because it's not just the fact that it's a pen, it's also the circumstances it's going to exist in. In a marine environment, salt water eats everything. Water always wins. So do you need your pen to be robust enough that it can handle getting splashed and wet? Pretty sure that'll fry out Alexa real quick. So now you've added complexities or found a reason to simplify. And it's we all, going back to what Ben said, we really need to figure out what it is that we want to achieve with this and what's the end goal. What is it that it actually needs to solve? Because if all you need to do is sign the check, you just need ink in a tube.
Yeah, and I mean, what the question, what makes a good pen? Well, that's subjective to begin with, right? So it's an opinion question. So that's the key part of the question.
But based around what the three of you have said, sorry, Gary, let me jump in. There are a certain number of things, like me challenging 3 incredibly smart guys to figure out how to build me a better pen, down to the point where we can build one that geospatially knows where it is, can be far more useful than just the ability to write. And yet you guys have also addressed, without even asking me once, what I really want to do from a final function. Because if I had to answer that question, if you'd asked before, I'd say, well, actually, I've got an endless series of these sitting here. I just want to write notes. And then one of the first thing any of the three of you would say is like, well, why are you writing notes on a piece of paper still when you could have a digital tablet? Or why bother with even a digital tablet if we go down the path that Gary talked about as well, where I've got the pen sitting in space right now? And what if it's so smart that as I write on the surface of the really fancy desk I've got right now, because it's not going to scratch the surface because the material's so tough, it shows up on the screen, which means I've just eliminated the stack of books that I jot notes in effectively. So each one of these, by iteration, by ask and design, we also look at things like budget, etc. Right?
You also got to look at market as well. Because at the end of the day, is there a market for your product? I mean, if you're just getting another pen that's a tube with ink in, there are thousands of those. I've got catalogs here that's got 3,000 different pens in. Every single one is different, but they all do the same thing. You're competing with a saturated market. So if you want a differentiator, is there what's the differentiator for your pen? It's not going to be that it's $1,000, because that people won't care about that. They'll care, can I write on a piece of paper? If they want to do more with it, that's when it starts to differentiate.
And it's also a question about scale too. Building one pen is a lot more expensive per pen than building 100,000 pens, right? So having that system of being able to replicate your process for building that pen is also critical.
Now, I want to point out what Michael said for a moment, because whether it is a common folk tale that we all buy or actually part of NASA's process to spend $1 million to build their space pen, one of the common narratives we always hear that came out after, which is to go to what you guys are talking about, is what do you ultimately need to do, but what is it supposed to do in the future? Because also part of that folk tale is the second part that says, well, the reason they decided to spend $1 million to design a pen when the Russians are like, we used a pencil, it's because at that point in time, they're going, well, hold it. Graphite can flake off of pencils. Graphite can get inside of our electronics, cause fires, and burn spacecraft to the ground. Now, is that a really good narrative to explain why we spend $1 million building a pen that can write in space and doesn't explode in your pocket when you go through atmospheric changes, getting to outer space? Or is it just a really good thing to say, well, crap, we spent $1 million making a pen, and now we have to come up with a good story because the Russians just use pencils? You know,
But it was-
do we have to, and
probably-
this is not a narrative east versus west. It's just go, well, did we have to justify it, or were they thinking ahead and future proofing the process by saying, we'll spend $1 million now, but to design something that, yes, one, it's just going to write on a piece of paper, but two, it's also going to sit in your pocket, and atmospheric change pressure, being in a suit, being in a capsule, coming back and forth through the atmosphere, et cetera, is not going to affect it at all. Were they smart enough to think that far ahead, or is it just a really good story?
The other thing is, are you allowed a sharp knife to sharpen it?
Well, or the flip side is that, like, you know, working in construction, your pen breaks on a job site and you're 10 miles from town. A pencil, chances are you can figure out a way to sharpen it or make it work. Your pen busts, your pen busts. Like it's all of that, and it really comes back to figuring out what it is you need to do. Like there has, and ultimately planning any project, any execution. I mean, it comes down to putting a box around it to start with. You have to start with something, because otherwise you won't ever start. Like ultimately, like building cool shit, like it comes down to defining a problem, putting a box around it, and then starting to work on it. It might take you in a completely different direction than what you thought. It might turn into something completely different in application, in terms of execution, product, you name it. But I mean, you got to define your problem and start there. Like that's the first step on everything.
So if we were going to educate, Gary, go ahead.
Yeah, as I say, you may even get the auditors involved. And I say that seriously, because at the end of the day, if you're in space, you're writing records that need to be kept. If you're actually writing in pencil, they can be altered. If you're writing in pen, they cannot. And it may have been something just as simple as you can't use a pencil because it needs to be a permanent record. So, you know, simple things, but it's down to the requirements. It always comes back to, what are you defining as requirements?
If we take the device and the software that goes in there, or what's enabling us to talk to each other right now, or to broadcast to the entire world through YouTube, for example, for us to sit in our homes or our office variedly in comfort in the middle of winter, to sit with our homes and businesses on streets with the infrastructure that goes with it or everything else, it all starts the same way. So I'd like you guys in the next 5 minutes, so here's your intellectual challenge, to educate people on how to plan to solve their own problems, because building cool shit all follows the same thing. I can ask you again, what kind of cool shit? What I really want you to do is help people to figure it out, because most people are actually terrible at solving problems. And yet building shit, building the stuff that's, whether it's the better pen that's going to end up costing $1,000 right now, but in 2 years we can get it down to $5 and does everything as Gary was outlining in the initial iteration of the pen, or the software that goes in to talk to it, or the way that we're going to sell it, communicate it to people, et cetera, or even the materials we're going to be able to write it on, or the facets we're going to be able to use it in. It all starts the same place. It starts with an idea, or the fancy word's ideation. And from idea and ideation, we always want an outcome. So what is it that we want to do? What is it, should it do? What is it that makes most practical sense? And then what's going to match the need or the want? And then from there, we start talking about actually designing and building and troubleshooting and problem solving and final implementation. So I may have just summarized a little bit, but I want your guys thinking on, if you had to educate somebody else and say, listen, this is going to be your playbook. This is going to be your cheat sheet. You're going to be able to write it down with that brand new pen on the surface of the desk, and it's going to show up on your screen. And here's how you're going to fix all your problems in life, because building cool shit really only works a handful of the same ways to start with. From building software to building city streets to building a sign, IT infrastructure, and one idea to build the best pen on the marketplace. I've heard the similar things out of all three of you today. And that's really what I want us to drill down to. So let's educate people on how to build cool shit. Because if I've heard you right, it really doesn't matter what we're building. We tend to go through the same steps regardless. Am I wrong? All right, so where do people start? What should people start with?
Actually, what Ben alluded to earlier, and that is, what's the problem you wish to solve? Pick a problem. Because at the end of the day, if it's not a problem, then you haven't got anything to do other than replicate what's already there. If it's a problem that somebody hasn't been able to fix, then it's a good way to start looking for a solution.
Okay. So we've picked a problem. What's next? What's our next step?
Planning.
Sorry, go on, Michael.
Well, I was like touching on what Gary said and what Ben with planning. I mean, like, I think that the biggest part of it is actually starting. I mean, that, like, talking about how to get started is to actually start. I mean, and it sounds stupid, it sounds redundant, but I mean, we all do it. We all sit around and complain about something, whether it's politics or healthcare or the way our TV looks or the way something is. Like, we all have problems that exist in our lives, whether they're big or small. But I mean, how many people actually act on it? How many people actually identify a problem, whether it's real or imagined or otherwise, and actually do anything about it at all? Like, I think the first step in that we have to do before anything else is just start. I mean, from there we can identify the problem, start putting parameters around it, start planning, figuring out all the rest of it. But I mean, so many of us don't start with anything. You want to build something cool, like, just go do it. Like, just start making mistakes and screwing up. And there's guys in India who you see news stories of who've planted entire forests that are now being used to repopulate tigers. Like, that was one guy with a pickaxe that decided, you know what, I want to do something different. And like, that's, to me, that's the definition of building cool shit, is just getting started. Like, all four of us on this chat are building cool things that are completely different because we all just one day decided to start. And if we didn't, we'd all be still working for somebody else or doing something else. And you know, I think that's a big one for doing all of this.
I think one of the things that I mean, if I come up against a problem, the first thing I do is I do a market scan to see if there's an existing solution, because it's far cheaper to actually have something that's an existing solution to go out and develop a new one, especially if it's only for a single problem. If I don't find anything that's even close, then it's a case of you start looking at defining what the problem is in the context of what's it stopping you from doing. Are there workarounds that are effective? If there's no workarounds, then you've got to fix it. And that's when you start then actually doing the design based on the requirements that you've actually defined.
It's a bit of a running joke in my line of work, in that, you know, I get lots of people coming to me with app ideas, and like a little bit of an eye roll there, and you know, I'm pretty patient listening to people usually, but you know, the first thing I usually ask them is, you know, is there something out there already, right? Like Gary alluded to. So, but the nice thing is there is so much available in the form of open source code or purchasable apps that do maybe 80% of what a business might want. And that shortens the time to get to where they want to be. It might not provide the complete solution, but it'll give them a good head start at least.
So if I can summarize where we're at right now, identify the problem. And on top of get started, look for a problem that you have, that you're identified right now with a solution that may already exist. If it doesn't, get started, and to get started, begin to plan. And I would assume consider the outcome in mind. If I know what the problem is and I can't find a ready-made solution right now to get started, then I'm going to have to do some planning and implementation, but I'm also going to identify what I want at the conclusion. If I've got a problem, what is my conclusion and solution supposed to look like? Would that be a fair estimate or summary?
Yeah, and you can also add, what are you willing to compromise on? Because there are some projects, particularly in the IT space, where people don't want to compromise, and the cost becomes astronomical because of that lack of compromise. There are some very good apps out there, and when you look at them, they might not be 100% of what you need, but if it's 80 to 90%, you may be able to change your business process or whatever it is that the app is doing to actually meet what you require. and it means you get more efficiency from the 80%, you may lose a little bit from the 20%.
I see Michael nodding his head. I am assuming very much that in the real world of construction, this is often the argument as well between what we really want and what we're really going to turn out at the end.
Oh, 100%. And I mean, like, especially, you know, the most obvious one that people probably come across on a daily basis right now is with developers, you know, especially I use Edmonton as an example. Lots of people have cool ideas about what that development is going to look like. And then then they get approval and they're going through it, and really quickly they realize that, hey, to build it that way is going to cost this much more money than we wanted. So then you know, they peel it back, and eventually they end up with kind of a generic looking box that looks like a lot of other stuff. And it's sad that happens, but I mean, it's also goes back to poor planning. Like, if you want it to look a certain way, you should be able to figure out what that cost is going to be and account for it. And not to say that circumstances don't change. Tariffs get put on steel unexpectedly, and all of a sudden your project cost jumps 30%. You can't account for that. But there's so much that has to be give and take, and there's always going to be stuff that has to bend to the will of reality and physics. Architects love coming up with some pretty impressive structures, but I mean, you can't hang 40 stories off the side of a cliff because the cliff won't hold it. Like, it, you know, but maybe you can come up with a different approach that it's not as big, but it's still as tall, and achieve that. There's always compromises on a project.
So identify the problem, look for ready-made solutions, start, plan, problem solve all the way through, alter your expectations, conclusion. Because whatever the problem is, you're looking for an outcome that satisfies the solution, not satisfies the want or the need. Yes, no?
Depends on how hard you want to hold to it.
There is one piece that you need to add to that as well, and there needs to be a feedback loop. If you're building something that you intend to repeat, then you need to have feedback from the end result to see whether you need to change for the next build. Because then, and it may be feedback in the context that's beneficial to you because it actually makes the second build faster or more cost effective. But you do need to have that feedback no matter what it is. You need to make sure that it meets the expectations, and if it doesn't, what do you change for the next time? And the pen is a good example of that.
And, you know, even to add on to Gary's there, you know, perhaps the last thing to consider is the operations and maintenance. You know, as a pen, you're going to need refills, right? How much do those refills cost? It's like the old printer joke, right? The refills cost more than the printer. People just buy new printers. But whether it's, you know, a physical piece of technology or digital, there's operation of that to maintain and continue, you know, provide continuance of that product.
And actually, one thing to consider that, particularly in Ben's arena, and that is the fact that the changes or the updates that you do on software may become outside of your control, because if it's an operating system change, it may make your software obsolete. And it's very prevalent, particularly in the Windows space.
So we can update that very first box that says identify what the problem, and then identify the input that could come in from both outside and inside that changes the context for how you need to satisfy that problem, because there may be input that you don't realize that you're going to want to account for when you finally get to solution.
Yeah.
So we're going to look at the problem. We have to look at all the input that's going to come in, the things that could change the environment for how that problem is going to be solved in whatever we build. From there, we're going to go to that start. We're going to do some planning. We're going to have feedback as we move towards the solution. And then we're going to, if we got feedback, then I'm assuming we're also going to have adaptation. because as we continue to work through the problem, there's inevitably going to be challenges in the form of the conversation where it comes to budget considerations, rework, outside stimuli that changes as we come through the system until finally we get to the solution. Our initial problem may have changed very drastically for the way we understand as we're planning and actually going through it, and as we get feedback to how that solution is going to finish up.
Well, and it's true across the board. You see it all the time. I mean, I bet you at some point, if you went back in time, Blockbuster was trying to figure out what the next thing after DVD was. They didn't realize it was going to be nothing. There was no hard copy after DVD because it became digital. You know, the companies that did realize that, they're the ones dominating now. There's always a reality that the next thing might be that it ends. Horse and buggy, you know, short of Amish or Mennonites, has gone away. The guy who was trying to develop the best horseshoe on earth, Ford kind of threw him for a loop because there was no more horseshoes.
I love the fact for a moment I'm going to back up to Blockbuster, and then we're going to wind down because our clock's coming to an end today, and then get to some final thoughts from you guys. Because Blockbuster, when you looked at the initial problem, Michael, I love the way you framed that, was to find the next thing that came after. And at the time, we all know the story about companies that Blockbuster had the solution presented to them when they were offered to buy Netflix. And then they ultimately said no, because Netflix started the mail order process for mailing movies to people. If Blockbuster had an opportunity to buy them, and now we're at, what is it, an Instagram or a Twitter account for the last Blockbuster in North America. And it's become a little bit of an internet sensation. And yet Netflix, every one of us has probably gone on to Netflix in the last 24 hours and watched a movie. So that's where the problem, we didn't identify enough outward stimulation or enough outside influence to change the way we were ultimately going to the solution, which was not finding the next hard copy, but just finding the next way to deliver movies to people in their homes. So Netflix started delivering it to your home so you didn't have to go anywhere. And then Netflix turned to where all you had to do was turn on your phone or your computer or your television and watch it directly. And meanwhile, Blockbuster was still trying to figure out just how to get another DVD to you. Final thoughts to close out for the day. Gentlemen, building cool shit is both complex and yet really simple if you start with the problem in mind. Most people want the solution. I want the best pen money can buy. But I've heard today from three of you, from an engineer, from an IT architect, and a hands-on builder, and a software engineer, that you just want to know what it's supposed to do at the end. But the problem really is, what are you trying to do with it to start with? I want the best pen. In fact, Gary, I want the pen you designed right here on Build Cool Shit on Syndicate Talk Season 2. So I guess we have to talk after. And the four of us have a very different thing to do. But it always starts with the end in mind. What do you have to do with it? What problem are you trying to solve? Are you trying to go to space? Are you trying to take it everywhere and it's all things to all people? Does it have to connect to the Internet of Things? Or do you just need to jot notes? What's going to be the end solution, but what's the problem in mind? What does this really have to satisfy? And then from there, to Michael's point, just get started. Allow for feedback and reach the natural solution. Ben, Michael, Gary, final thoughts. Building cool shit. Ben, go ahead.
You know, one thing we overlook when we talk about building cool shit is, you know, just building it isn't enough. And this is more your domain, Mitch, is you have to market it. You have to sell it. Otherwise, there's no point, right? You're not making any money off of it. And the myth of, you know, if you build it, they will come, you know, doesn't work, right? So marketing is also very important.
Michael, final thoughts?
I look at building my philosophy, like as much as I'm an engineer and I build physical things, I've really become philosophical in recent years that like building cool shit, I don't define what cool is. I don't define what cool shit is, because the reality is that similar to what we're talking about, it's anything. It's, to me, building a marketing campaign is just as valid as building a house. Building a business is just as valid as building a bridge, a car, an app. There's a million different things that can be quote unquote built. And I think that we all, society, not just us, but like I think we all need to take a closer look at the fact that all of this stuff gets built. Everybody builds stuff every day. Stay-at-home moms, I would say they have one of the hardest jobs on earth because they're building kids. Like, you got to stock that furnace of energy that they got and train them in languages and social skills. And like, that's what has literally driven us to where we are today as a society. That's one of the hardest jobs there is to build a happy, healthy kid. We need to take a broader look at what we can all build.
Gary, final thoughts?
Interesting that, we're talking about problems that people have. One of the things that's coming online, albeit rather slowly, is smart city, industry 4.0, and it's the advancement of the Industrial Revolution. So with Industrial Revolution 1, you had the introduction of steam and water power. Industry 2, you had using electric power for mass production. Industry 3.0 was the use of computers and robotics. And now we're coming into Industrial 4.0, which is the Internet of Things, industrial automation, machine learning, and AI, what people know as AI. That's going to have a big impact on the future of people. And it's whether they will have the ability to think for themselves at that point. So unless people keep their imagination, they're going to lose it because the machines are going to start thinking for them. And it is coming. For example, there are now buildings that when you actually put your smart card against the reader when you're entering the parking lot, okay, it knows you've arrived. It knows the meetings you have for the day. It actually has assigned you a hot desk in the office. It sets the temperature that you prefer for that environment. It knows the meetings and it's assigned you a meeting room. So it's doing everything for you. You don't even have to think about what you're going to do for that day other than the tasks that you have assigned. So in the context of everyday living, it becomes very valuable because you don't have to worry about whether you're actually going to be fighting at the thermostat with your neighbor. But it also means that it starts removing people's imagination. So the more opportunity people have to imagine what they want, I think it's going to be a very valuable tool for the future.
That is what it takes to build cool shit. Brothers, I waited all session to have somebody say imagination. And I love the fact that it has come at the end. Because above all else, if I can summarize as we close out, and I see everybody smirking and smiling here, not a single one of you would be doing the professions that you are doing right now, the things you do in life to build cool shit, whether digital, virtual, physical, home-based, societal, in size, etc., for pleasure or for purpose and profit. You do it because it allows you to use your imagination. It challenges the brain. It allows you to solve problems, complex and simple, the very beginning of all of this, but at the end, it's not losing imagination, allowing you to think in ways that, well, most people aren't being challenged to. And to Gary's final thought, imagination is going to be incredibly potent and powerful because it's still something that the machines don't quite yet understand. And it might be our most humanizing aspect when it comes to building cool shit, because whatever we can create inside of our mind, we have the opportunity to potentially build out here. Ben, Michael, and Gary, thank you. Thank you for sharing what you guys are expert at, and thank you for taking this path. this unstructured approach to helping people find a small way to frame. Now, building cool shit, weirdly enough, is how you fix all of your problems in life, wouldn't you say? Start with the idea in mind, identify your problems, look at the things that can affect that from the outside and inside. Just get started, create a plan, have some feedback, and watch for the solution. See what the solution comes to solve the problem at the front end. And from there, have an opportunity, big and little, from just the pen to the pen 2.0. You have a chance, thanks to imagination, to express, explore, experiment. And we heard from all three of you that it's okay to make mistakes. Just do it. Do it. Get started. Make some mistakes. Look at iterations. Learn from it. Create something better. And of course, use your imagination. Gentlemen, thank you so much for joining me. For our live audience, thank you for joining us for the final episode of Syndicate Talk Season 2 during 2020. Of course, the rest of Season 2 is going to be coming in January, but right now we're going to be pausing for the Christmas break. Please follow along for the first start of Season 2, for all of Season 1 that's out there before. Come and find these three fine human beings and ask them how to build cool shit in your life, from what makes the world work outside of us, to the home we sit in right now, to the Internet of Things and technology, to something as simple as just a sign hanging on your wall. Find people that are incredibly smart at what they do, ask them to help you solve problems and build cool shit with you or for you, or to help you build it yourself. And life will be a little better because of it, because at the end of the day, it means that we allow our imagination to run wild. On behalf of myself, my partners, one of who that is on this call, Ben, wave a little bit. Thank you so much for joining us on a Syndicate Talks Season 2. Merry Christmas to you. Trees up. I've got to say that out loud. And of course, we will see you all in 2021 at our next event. Have a fantastic day. Have an enjoyable season, and we will see you soon.